Okay, in this little demonstration, what we're going to do is take a look at the solubility of solids in solution in comparison to temperature. Okay, so in our setup here, I have 60 grams of potassium nitrate solid right here. And potassium nitrate we know to be an ionic compound, so it will be an electrolyte once it dissolves. That can become important for us. And then in each of the beakers here, I have 100 milliliters or 100 grams of water. Okay, and what we're going to do is we're going to put them both together, start them at the same time, and we're going to take a look to see how the solubility is affected by temperature. Now, on my side over here, this is going to stay at room temperature, and all this device is doing here is it's stirring the solution for me. On my left-hand side or on this side over here, this is going to warm it up and stir both once we get started here. So I'm going to get this thing stirring. Back it down a little bit. There we go. And then I'm just going to add the potassium nitrate to both solutions at the same time. Our goal here is to try to not let the stirrers stop moving. They both seem to be working okay. This guy's struggling a little bit. We'll turn him up a little bit as we keep going here. And then, now we'll turn the temperature on, okay? So initially what we're going to see is that when potassium nitrate dissolves, it's actually an endothermic process. So potassium nitrate, the process of it dissolving actually pulls heat energy in. So it's going to cool the solution down. So we should be seeing that temperature drop initially, okay? Now, for the one that's not being warmed up, that should eventually level off for us or maybe continue to drop. The one that we are going to artificially warm up over here, so for this one, when we start looking at this, eventually the heater is going to take over and it will actually warm it up more than it is cooling down. Okay, so we'll let these things run and we'll check back here in a minute. Okay, so at this point in time, if we take a look at our two solutions, this solution over here has increased in temperature, and we can see that looking at our graph. This one over here has dropped in temperature and has pretty much stabilized at that temperature. And the big thing we want to look at is the amount of solute particles for each one. So the one that was being warmed, there is no solute particles left. The one that was not warmed up, there's plenty of solute particles left. Now, I could sit here and I could let this run all day. I could let it run for a week. I could let it run for 10 years. As long as we didn't let this water evaporate or that water evaporate, this beaker will never dissolve those particles. Okay, we've reached what we call as the saturation point for potassium nitrate here. Okay, the absolute maximum amount of potassium nitrate that can dissolve in here has done so. Doesn't matter how much stirring I do, doesn't matter if I crush it up, doesn't matter if I agitate it. If I don't change that temperature, this is all it can dissolve. Okay, no matter how much time we have. However, over here, okay, in this beaker, we've dissolved all of it. Okay, and I actually could continue to add more if I wanted to. So we haven't reached the saturation point yet. I could add even more of that potassium nitrate in. Because we've warmed it up, we've increased the solubility of the potassium nitrate in water. Okay, so if we go back to our information on this, when it comes to solids and their solubility, we know that solids, as you warm up those solutions, solids become more soluble. Okay, once again, it's completely gone already. All right, I could probably add in another scoop, even another scoop of it, because at high temperatures, potassium nitrate has a really steep solubility curve with it. Okay, so again, the demonstration here is just to help remind us that when it comes to solubility, temperature is a factor. Okay, in that, for our solid solutes and for our gas solutes, for our solid solutes, and in this case, with our solid solutes, as the solubility, as the temperature went up, the solubility would go up. For our gas solutes, it would go down. Or sorry, on this side we didn't change temperature, so it wouldn't affect it. Now, we do want to talk a little bit about the gas solutes, because the gas solutes are also part of this scenario. For gas solutes, the exact opposite is true. Okay, so for a gas solute, when you warm it up, its solubility will go down. So it has the opposite effect there. Okay, and again, we go into our notes to talk more about the reasons why. Thank you.